All right, Intermediate Algebra Homework 36 is starting out with what's known as the Pythagorean Theorem. Some guy named Pythagoras figured out that if I have a right triangle, there's a right angle in there, that the sum of the legs squared, the legs are the two short sides, is equal to the hypotenuse squared. The hypotenuse is always the longest side. So the formula looks like this. A squared plus B squared equals C squared. Keeping in mind that that is the hypotenuse. The hypotenuse is the long side. The longest side is always opposite my right angle. So I want to use my Pythagorean theorem to find the length of x, round my answer to the nearest hundredth. So this would be my A and my B side. This would be my C side because that's my longest side. So 9 squared plus 11 squared is going to equal x squared using the values that they used. I would then want to calculate that. 9 times 9, 9 squared, 81. 11 times 11, 121 equals x squared. I am then going to go ahead and add my 81 plus my 121. And I get 202 equals x squared. Now we need to solve that for x instead of x squared. So we do the opposite of squaring in order to solve that. The opposite of squaring something is taking the square root. So in order to find x, we're going to do the square root of 202 on our calculator. So square root of 202 gives me 14.212 . We want to round our answer to the nearest hundredth, so we need to carry this at least 3 places because the hundredths is 2 places. Since there's a 2 behind that, we're going to round that off to 14.21. So x is going to be 14.21. The second one, for the following right triangle, find the length of the side x, round your answer to the nearest hundredth. Again, we want to make sure that the two short sides are our A or B, the long side is the C. So this would be A, this would be B, this would be C. The long side is always opposite that right angle. So I would say that 10 squared plus x squared is going to equal 11 squared when I set up my formula. The sum of the two short sides squared is equal to the longer side squared. 10 squared is 100. 11 squared is 121. If I want to solve this one for x squared on this one, I've got to move my 100 over to the other side. So I'm going to minus 100. X squared is going to equal 21. Again, in order to solve this, I do the opposite of squaring. I'm going to take the square root. The square root of x squared is x. The square root of 21 I'm going to do on my calculator. I get 4.58. I'm writing my next number down. 4.5825. I'm rounding it to the nearest hundredth, so 4.58 is going to be the length of that side. The third one, again using my Pythagorean theorem. First thing I want to do, figure out which one's on my short side, which is my long side. So I'm going to have A, B, and C. By the way, if you switch the A and B around, it's the same thing. As long as you've got the long side by itself. So my Pythagorean theorem would say x squared plus 10 squared equals that longest side squared, 13 squared. So x squared plus 100 equals 169 if you take 13 and square it. Again, to solve this one, since I want the x by itself, I've got to minus the 100. X squared equals 69. In order to get that just a plain x instead of an x squared, I do the square root of both sides. And so the square root of 69 gives me 8.3066. I want to round it to the nearest hundredth. Because there's a 6 behind there, I have to round that one up. 8.31 is going to be my answer rounded to the nearest hundredth. we're going to get into simplifying some radical expressions, things with square roots. Number 4, we are doing the square root of a perfect square monomial. In other words, this should come out to a perfect square. When I do the square root, I'm thinking, what times what gives me this answer? Well, I would do the square root of 4. The square root of 4 is 2. 2 times 2 is 4. When I do the square root of y to the 8th, I'm trying to figure out, well, what times what gives me y to the 8th? What happens is because I add my exponents, I have to take half of that. This is a square root. It's understood that that's a 2 in my index. So I would have half of 8, which is 4. The square root of 4y to the 8th is 2y to the 4th, because if you take 2y to the 4th times the second 2y to the 4th, 2 times 2 is 4. I add my exponents. 4 plus 4 is 8. No radical left over because that is a perfect square, and so the square roots canceled out. So if I'm going to do the square root of 16x to the 12th, I'm doing the square root of 16 is 4. The square root of x to the 12th, I do half of my exponents. You can almost read that's a 2. Half of 12 is 6. If I took 4x to the 6th times 4x to the 6th, I get 16x to the 12th. And so number 6, I'm not going to move the board, I think you can still see it. Square root of 36w to the 4th. Square root of 36 is 6. The square root of w to the 4th, half of 4 is 2, going to be w squared. If I took 6w squared times 6w squared, I would get 36w to the 4th. So whenever I'm working with radicals, I am going to take the index and divide it into the exponent. 8 divided by 2 is 4. Cubed root of an integer. When I'm thinking about a cubed root, I'm thinking what to the 3rd power gives me the number underneath. The cubed root. So I'm thinking about cubed root of negative 8. What times what gives me negative 8? Well, if I do 1 times 1 times 1, I only get 1. 2 times 2 times 2. Oh, I get 8 there. I want a negative 8. If I did negative 2 times negative 2 times negative 2, I get negative 8. The cubed root of negative 8 is just negative 2. What number to the 3rd gives me negative 8? A negative 2 does. If you look at your calculator, you do have a cubed root button. Oops, I hid my calculator. The cubed root button is right above the cubed button. The cubed button is way on the right-hand side. Under that first gray button, you see x to the 3rd power. Above the x to the 3rd, you can see the little cubed root symbol. So you would do shift x to the 3rd, then I would put in my number, negative 8. If I do that, hit equal, sure enough, I get negative 2 on my calculator. So shift the x to the 3rd button, gives you this on your calculator, type in the negative 8. When you hit equals, it should give you negative 2. What's the cubed root of 64? What times what is 64? Well, we know it's not 1 or 2. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27, not 3. 4 times 4 times 4. 4 times 4 is 16. 16 times 4, is 64. So the cubed root of 64 is 4, because 4 times 4 times 4 was 64. Find the value of the cubed root of negative 27. Well, if you look at the ones we already did, we said 3 times 3 times 3 was 27. Since I want a negative 27, negative 3 times negative 3 times negative 3 is going to be negative 27. So, when you're doing cube roots, you want to think of your perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and you could keep going with your list. 5 cubed, 6 cubed, 7 cubed, and so that when you're doing these, you don't have to always think about, well, what number should it be? I know you could also use your calculator and figure it out. My 3 doesn't look like a 3 much there. But that's what you're thinking. The farther you go into math, the more you want to have some of these things memorized, because you don't want to have to look it up or punch it in every time. If you just know 3 cubed is 27, it makes life a whole lot easier. Especially when we get to the next ones. The next ones we are doing rational exponents. Those are ones that have a fraction in it. I can rewrite a fractional exponent by changing it into a radical expression. This is equal to, and the denominator is the index to your radical. So I would say the square root of 4 to the 5th. Now I really don't need the 2 for square root, but if it was a cubed or a fourth or whatever, I would need to put the 2 in there. So when I simplify this, if I'm not using my calculator, I do the root first, because then my numbers aren't so big. If I wanted to do 4 to the 5th power, I'm going to get a really big number. So do the square root of 4 first. The square root of 4 is 2. Then do the exponent, 2 to the 5th. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2, 32. Now again, yes, you can check these with your calculator. I prefer you do them the long way, because again, if you go farther into algebra and you start throwing variables in there, you're not going to be able to use your calculator much. So you need to understand the process. Here, if I'm going to do this on my calculator, I need to be careful that I put the fraction in parentheses. If you don't put the parentheses around that, the calculator is going to do the exponent before the dividing. So you have to make sure you use your parentheses. 4 caret parentheses 5 over 2, and if you hit equals, sure enough, I get 32 on my calculator. So do them on your paper, check them with your calculator. This one would mean 27 to the 2/3 power, the cubed root of 27 squared. I'm going to start with the cubed root of 27. Well, we just were working with perfect cubes before. We said the cubed root of 27 was 3. I'm then going to do 3 squared. 3 squared is 9. So 27 to the 2/3 power is equal to 9. Number 12. I have 16 to the 5/4 power. So the 4th root of 16 raised to the 5th power. 4th root of 16. Now that one's a little bit harder to do. We know 1 to any power is 1. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, sure enough, is 16. So the 4th root of 16 is 2. 2 to the 5th power. Now I got to add another 2 to that. 16 times 2, 32. So again, like I said before when we were doing the cubed roots, it's going to help if you also have a list of your perfect 4th powers and your perfect 5th powers. 2 to the 4th is 16. 2 to the 5th is 32. 3 to the 4th, what is that? 3 to the 5th. You probably don't have to go very high on your 5th powers because you start getting big in a hurry, but I would, at least do a few of them so that you've got a list handy and you start getting used to knowing 2 to the 5th is 32, so you don't have to look it up or calculate it every time. Makes life a whole lot easier. So once we did that, now we're going to throw in both fractional exponents and negative exponents. Keep in mind that if the exponent is negative, you end up having to do the reciprocal of the base. So this first one here just has a fraction, has a positive exponent. So I'm going to do it just like I did the previous ones. I'm going to have the square root of 1/9 to the 3rd power. Square root of 1/9. Think about the square root of 9. The square root of 9 is 3, so the square root of 1/9 is 1/3. I'm then going to take 1/3 to the third power. I should really probably put parentheses around those just because it's a fraction. 1/3 to the third power. Well, 1 to any power always stays 1. 1 times 1 times 1 times 1 times 1 times 1 times how many ever ones you want to do is 1. The 3 to the third power, 3 to the third power is 27. So again, if I were checking that with my calculator, I'm going to put parentheses around any of the fractions, even though on here it doesn't show parentheses around that exponent, but the calculator needs it. So I would do 1/9 to the 3/2 power. In parentheses, 1/9 parentheses to the, in parentheses, 3/2 power equals, I got to get it typed in right yet. There we go. And I would get 1/27 on my calculator. Now on this one has a negative exponent. If you have a negative exponent, you do the reciprocal of the base to make your exponent positive. So in this case, I'm going to rewrite this as 1/32. The reciprocal of 32 is 1/32 to the positive 4/5 power. Now that my exponent is positive, I can do my problem. So I'm going to do the 5th root of 1/32, raise it to the 4th power. So I think about the 5th root of 32. Well, on those previous problems, we did 2 to the 5th power. 2 to the 5th power was 32. So the 5th root of 1/32 is 1/2, 1/2. I'm then going to raise it to the 4th power. Again, on those previous problems, we did 2 to the 4th power. 2 to the 4th power was 16. So I'm going to get 1/16. So 32 to the negative 4/5 should be 1/16. 32 caret, in parentheses, negative 4 fraction 5ths power. I get a decimal on my calculator. I get 0.0625. But if I hit shift and the fraction button, change my decimal to a fraction, oh, now it shows up as 1/16. Yep, I did it right. So, again, do it on your paper. Check it with your calculator. I'm not going to do any more checking. I'm just going to work them out. Here again, I look at this and say, oh, my exponent is negative. I've got to do the reciprocal of 81. 1/81 to the positive 3/4 power then. I'm then going to do the 4th root of 1/81, and I've got to cube that answer. 4th root of 1/81. Well, we did 2 to the 4th. That was 16. What was 3 to the 4th? 3 times 3 is 9. 9 times 3 is 27. 27 times 3. Oh, there's my 81. The 4th root of 81 is 3. So the 4th root of 1/81 is 1/3. I then have to raise that to the 3rd power. 1 cubed is 1. 3. 3 times 3 times 3. 3 cubed is 27. So I get 1/27. The second part of this, again, this has a negative exponent. Since my exponent is negative, I've got to do the reciprocal of my base. The reciprocal of 1/32 is 32/1, or just 32. So I'm going to do 32 to the 3/5 power. So I have to do the 5th root of 32 cubed. The 5th root of 32. 2 to the 5th was 32, so the 5th root of 32 is 2. Then I'm going to do 2 cubed. 2 times 2 times 2. 8. So 1/32 to the negative 3/5 power should be 8. Number 15 is the last one on here. Again, if we look at that, the first one has a negative exponent. Since my exponent is negative, I've got to do the reciprocal, 1 over 32 to the 3/5 power then. I'm then going to do the 5th root of 1 over 32 and cube my answer. The 5th root of 1 over 32, 5th root of 32, hopefully you know by now, is 2. So the 5th root of 1 over 32 is 1/2. 1/2 cubed. 1 cubed is 1. 2 cubed is 8. 2 times 2 is 4. 4 times 2 is 8. This one, we have 1/9 to the 3/2 power. I don't have a negative exponent, so I'm just going to do the problem. I'm going to do the square root of 1/9 cubed. And again, you don't really need the 2 for the square root, but just to remind you where those numbers came from, the denominator is always your index here. The square root of 1/9, well, the square root of 9 is 3, so the square root of 1/9 is 1/3. I then have to cube 1/3. 1 cubed is 1, 3 cubed, 27. So 1/9 to the 3/2 power is 1 over 27. All right, that is the end of homework day 36.